Hi, this is lesson 7 in the use of JASP and learning more about statistics than you might have wanted to know. In the last few lessons, I have taught about how to do an independent groups t-test, how to do a within groups t-test, and I want to continue with the same data set. If we go to Open Data Library, Descriptives, and sleep. And I've been using this data set for all of these first 7 videos on JASP. And we'll remember that if you click over here, you get the data set, and that this data set is in what we call long form. That means that the data every line of data includes something about a dependent variable, extra hours of sleep, but it does that under various conditions. Here, condition 1, the first drug. Here, condition 2, second drug. But you'll notice that the data for the individual is being repeated. We're going to do a mixed models test, which is generally considered a pretty advanced test. We're going to see that there's a very simple version of this test in terms of what it does. So I'm going to take extra and put it over as my dependent variable, group, and put it over as my fixed variable, that is the independent variable. Let me move this over. You notice that it doesn't want to do anything here. It doesn't want to do anything yet because we haven't finished setting things up, because for a mixed models analysis, also referred to as a multi-levels model analysis, you have to specify a random effects grouping factor. Well, what random effects do we have? Well, like in most studies, we randomly picked 10 people from the population, supposedly. Hypothetically, it's a random selection. And hence, these individuals being a random selection from the population of persons we hope would generalize to the general population of persons. But we always have that random factor. We don't usually have to specify anything about it in particular. But in this long form data set, we have groupings of this random factor. And that's what this is asking about, the random effects grouping factor. So if I take the ID and put it over here, now this fills out. And now it is taking account of the errors structure, considering that these 2 people are the same 2 people, and these 2 people, person number 2, those are the same 2 people, and so on. That's the advantage. Now, what we have here in terms of this ANOVA summary is we have a F-test. And an F-test is, an F is basically the square of a T for very simple models. And in 2 videos ago, in lesson 5, I did a within subjects or paired t-test, and there we found that T was equal to 4.062. F is the square of T. So I'm going to square what we found before, and we get 16.499, or rounded off, 16.50, the exact number that you see here. Aha! This mixed models analysis, this very fancy analysis, can be construed as a way of modeling a within subjects t-test using the data in long form as opposed to wide form. It's giving you the same information. If I go over here to my estimated marginal means, I get exactly the same mean structure as what we've been dealing with for the last 6 videos. That condition 2 gives me an average of 2.3 hours of sleep. That's drug 2. Drug 1 gives me an average of 0.75 hours of sleep. Looking through here for plots, there's my plots. And it's basically the same information that we've gotten before. You'll notice that they went with a jitter width that was kind of small, jitter height of 0. That was actually my selection uh, uh, for one of the videos that I did, saying that I think that this data structure, doesn't need that much jittering. And here you'll notice that it's actually picking that out better than some of the other defaults, and setting it up uh, in that way. You can add on a color element. You can spread this out. It's basically the same data that we've had before. Unfortunately, I don't see any way of connecting the lines. And, that's essentially what this analysis is about. Let's see if there's other information here to pick up on. Under model, you can specify some other effects. Here we have information about that views this from what's called a general linear models perspective, or regression perspective, where it's basically looking at this effect and coding it in such a way that it gets out an intercept and then an effect to represent our difference between the groups. And it's representing that difference between the groups as a minus 0.790 as the estimate. And here it's coming out with the exact same t value and p value as we got from a within subjects t-test, exactly the same. And again, this squares to exactly this value, and the p-value is exactly the same here. It's giving you exactly the same information as what you would have from a within subjects t-test, but for a data that is put into long form as opposed to wide form. There are other bits and pieces here, but I think you would need a lot more background in regression and other modeling techniques. This really is an advanced module, so I won't go into that. But I think it is useful to show you that mixed models can mean something that's pretty simple, but also highlight the difference between the long form data structure that this data originally came in, the within or wide form data structure that I demonstrated to you in video or lesson number 5. So with that said, I'm going to cut it off there, but there's a peek into mixed models.